Hello, my name is Levi Gomez, and this is my view assignment for Chapter 3, Question 22. The question is to determine the zeros and multiplicity of the graph, right here, and then write it in factored form, and then multiply it out into standard form, and finally describe the end behavior. Okay, so the first thing we can take from the graph is it makes contact, or the x-intercepts are -2, so x-intercepts are equal to -2, 0, and 2, 0. One other point displayed on the graph is the y-intercept, which is at 0, -8, meaning it crosses the y-intercept at -8. Okay, so from this, we can see that our zeros are going to be x plus 2 and x minus 2. So if we write that out in factored form, it's equal to a times x plus 2 and x minus 2. One more thing we're going to take from the graph is the multiplicity of both of these intercepts. So from the graph, when we see when it makes contact with x minus 2, or x equals -2, you see it bounces off the x-intercept. That trait is common with squares, so we would square this. And then the x-intercept of 2, you see it goes through like a clean plane line, common trait of singular normal lines. Okay, our next step is we need to find what a is. So we need to plug in a point that isn't one of the x-intercepts or the zeros, which is given the y-intercept of 0, -8. So when f of 0 is equal to, so we already know it's going to equal -8. It's equal a, substitute 0 for x, plus 2 squared, times 0 minus 2 to the first power. Okay, this is going to simplify it out to -8 is equal to a times 4 times -2, parenthesis, which is then equal to -8. A is equal to -8, which is just 1 is equal to a, once you divide both sides by -8. So the final factored form is equal to f of x is equal to 1 outside of x plus 2 squared times x minus 2 to the first power. Okay, now we need to bring this into standard form and multiply it out. We can ignore these two ones because they don't change anything in the equation, so we'll just write f of x is equal to x plus 2 squared times x minus 2. Okay, this is going to simplify to x squared plus 4, better 4, times x minus 2. Now that we're here, we just need to multiply these two by each other. We'll do it one step at a time. So x squared times x to the third, x times 4 is plus 4x. Now we go to this, so -2 times x squared is minus 2x squared. And then times 4 is -8. Now once we get that all situated into the correct order, we get that is equal to x cubed minus 2x squared plus 4x minus 8. This is our final standard form. So this is our factored form right here, and this is our standard form. Okay, finally, our final step, we need to describe the end behavior. So based off the graph, you can obviously see it's going to go as x continues on to infinity, f of x or the y is going to go to infinity, and when x is going to negative infinity, this is going to go all the way down to negative infinity, the y. But we can also see from this first value, this first x, you see it's x to the third, to the cube, which in graphs also proves that it's going to look like this. While it may not look exactly the same, it displays the same end behavior. So in both the equation and the graph, we can see that that as x moves towards infinity, f of x also moves towards infinity. And as x goes to negative infinity, f of x also goes to negative infinity. Put a better infinity sign. It's good. So these are our final equations. I'll move this arrow, it looks like it's pointing. We make this as, I'll move it so it's up here, so it doesn't look like it's pointing at it. There we go. So, this is our work. You can see from the graph we get the x-intercepts and the y-intercept, or the zeros, and an extra point. Then we move it to factored form. We solve for the a, and then write the final form, the final version of the factored form. Then we multiply it out to get the standard form, and find the end behavior, which can be shown through the graph itself, or for the first variable of the polynomial. Thank you.